Bias variance trade-off is a topic that you would encounter while you are trying to improve the model's performance. So when you get into the dynamics of model calibration and studying the performance of a model, bias variance trade-off is a study that you will implement and understand how is your model performing under different scenarios. So what is bias and what's variance? Let's start with the simple terms. Now bias is the assumption that an algorithm makes about the structure of the data. Now, these are not the formal definitions. These are like I've tried to put forward the definitions in a more layman approach. So, if in case the algorithm makes a couple of assumptions about the structure of the data, it will fail to recognize the remaining patterns. Right? It can be specified as the average approximation error that the model will have over all possible training data sets. Now, similarly, variance is the sensitivity of the results on a particular set of points. So how does this tie to a real life use case? Now this is a very popular example used to demonstrate bias and variance trade-off. So let's consider the dartboard. Now the ideal scenario would be like you have bullseye and you hit a shot and then hits bullseye. And every time you make a shot, let's say with different angles and different positions, different speeds or velocity, it actually comes and hits the bullseye, our sweet spot. But then let's say you're considering bias. Now, when bias increases, what happens is your model has made some assumptions about the structure of the data set, which means that it has created some rules and it accommodates only one small portion of the entire data set. So, unfortunately, what happens is, irrespective of whatever force or speed you throw the dart at the dartboard, it will kind of always come and hit these secluded points in a different area. Like you won't see a lot of differences irrespective of different inputs. If you increase the speed, if you reduce the speed, if you change your angle, you won't really see any difference. It will all kind of come and sit around like one different area away from your sweet spot. Now that's a scenario which can be defined as high bias. Now, what happens with high variance is like for small improvements in your speed, small improvements in your angle and rotation metrics, you'll see huge variations. So when you threw a dart with almost like high velocity, it hit somewhere else, and with almost similar specifications when you threw the dart once again, it kind of hit at a completely different point. So what happens is the model is extremely sensitive on a particular set of points. So that's when you see high variance. You'll see the dart points which you hit on the dartboard scattered across the sweet spot. That's high variance. So we've considered high bias and high variance. Now the worst scenario would be you have high bias as well as high variance. That's a scenario where you have your model has kind of understood of approximate structure of the data, which is not really the right one, and then it is still sensitive to a couple of points. So you'll see, okay, fine, there's a specific area which kind of pops up when you're trying to hit the dart onto the dartboard. And then with small variations in your speed and angle, you kind of see huge variations in the outcome. But these are not desired use case. These are not desired outcomes. The desired outcome would be low variance and low bias. Now, in reality, achieving low bias and low variance is a very difficult thing. Like the moment you try to reduce the bias, variance increases. When you try to reduce your variance, bias increases. So there's a trade-off. Now, depending on how you have to decide like what kind of model do you want. Like, of course, the ideal scenario would be low bias and low variance. But in the moment you try to reduce one, the other automatically increases. So you have to do trial and error experimentation and kind of find the sweet spot between bias and variance. Now, extreme cases of high bias and high variance, we've already studied that. But then when you have high bias and low variance, that's a scenario where you have underfitting. And when you have low bias and high variance, that's a scenario where you have overfitting. So, like if you just dig deeper into the terms, you have a low bias, which means that you've not really created any assumptions about the structure of the data set. When you have high variance, you have extremely sensitive to a couple of data points, which means that you've unnecessarily created a lot of complicated rules. That's overfitting. Underfitting would be the learning capability of the model isn't really powerful. So what happens is Like when you talk about overfitting, you'll see great accuracy score on the training data set, but then extremely bad accuracy on the test data set. Now, what would be the definition of underfitting? Underfitted models will actually give you bad results on the training data set as well as the test data set. Like you won't really see that, okay, the algorithm is learning something, and hence the accuracy on the training data set itself will be bad, and the test data set itself will be bad. Like high bias and low variance is a scenario which is very undesirable. So, and similarly, low bias and high variance. So, there are different techniques that you will put in place, that they will put in place to actually overcome these scenarios. That is, you have high bias, low variance. What step would you take to go and improve the model? You have low bias and high variance. What will you do to go and improve the model? That's bias variance trade-off. I would highly recommend all of you to actually read further on this topic and understand this topic to a great extent. Now, a couple of points to remember. We've taken a very simplistic representation over here. Like it's difficult to actually talk about low bias and high variance for a regression use case. Sorry, for a classification use case. And then so that's the idea. But then I hope using these layman terms you kind of get an idea of what would bias variance trade-off be. Let's move on to the next topic.